Hello, welcome back to this Lumines puzzle series. It's a new day and full of new discoveries. Uh, I realized that I was recording the entire time with Flux activated yesterday, so hopefully that orange tint wasn't too terrible. I also had a discovery. Well, I haven't actually tested it yet, but I think I realized why I'm having this issue where if I move the grid origin somewhere, the grid seems to move twice as far, and I think I've narrowed down why that's the case. Maybe it's not twice as far, but maybe it's more than that. But I think that's because I didn't actually read the name of the nodes that I was using in the scripts here. It's called relative transform location, and so this would be relative to the parent object that we're adding the component to, and yet I was using the parent's location and then adding to it. So I was adding its location, adding the parent's location to the offset from the parent. So obviously that's not going to give the desired result here when we want the components to remain, attached to the parent root node in the bottom left corner. So I should probably just remove this and see if that fixes things. Instead of adding, instead of adding anything to these, we just plug these in directly to the X and Z components. So that really simplifies the look of the graph a lot, and it might actually improve the functionality. This may not actually, be necessary if we're not ever going to move the grid anyway, but we shouldn't have incorrect behavior in the logic that's just inviting future problems. So before I move this around too much, I should test it to see if it actually solves the issue. And look at that. Now when we move this away from the center, it's fine still. Away from the world space origin, it still stays how we want it. So that's a pretty embarrassing oversight from one of the first blueprints I made for this video. So that's one issue that's resolved. And I guess now we'll move on to adding more functionality. So last time we added the movement capabilities for the quad. So I think we should now move on to the rotation functionality. And what I mean by rotation is not literally rotating them around like a central point, but moving, say this is the 4 blocks here that the player is controlling, moving the block that's located here to, if we're rotating counterclockwise, this block ends up here, the block that was here ends up here, the block that was here ends up here, and the block that was here ends up here. So just translating the blocks, in a circle, not really, but from one quadrant to the other, so that the gameplay effect is that the player can situate their blocks where they need to make the matches that they want. So that is probably going to be significantly more complicated than the movement logic that we've implemented here, because each block needs to move to a specific location, and then we'll update the references. So what used to be called BL, quad underscore BL in the game mode, if we're rotating clockwise, the bottom left is going to go to the top left. And then, so what used to be called BL is now going to move up. And then we have to call what used to be BR is now called BL, because BR moved to BL's location. So to keep things straight, we'll probably call things like old BL and new BL if we use like temporary variables or something. And or we'll just update them in the correct sequence. But we'll need at least one temporary reference, I think, to like keep track of the thing that we started with, so that we don't overwrite it before we have written it to something else. But let's just get into writing the functions, I guess, and then we'll approach the complexities when we need to. So I'll just have a rotate counterclockwise. I guess we'll just do clockwise first. It doesn't really matter. But so we don't really need to call get quad elements for this, since we're gonna just need all 4 individual quad references so we know which one's which. You know, we could establish a convention where we'll know what's at index 0, what's at index 1, but for like self-documentation, we might as well just keep the explicit names of the 4 blocks in the quad. I realize I've been calling the 4 blocks in the quad, I've been referring to them as quads themselves, which is just confusing because they are, you know, they look like squares, which could be a name for quads. Whatever. They're blocks or tiles or whatever you want to call them. The individual slots, the units, the individual actors that make up the quad elements. So let's make a function. I guess we'll just collapse this to a function later. For now, let's just get things on the screen. So let's start at the bottom left, because that's what we did before, so why not do it again? Get quad BL. So I got halfway through implementing a rotation method for the quad when I realized what may be a superior method of implementing a rotation. Instead of actually translating the blocks like I was planning and moving each block to its new position and then updating the references, instead of doing that, which, you know, could work, probably would work fine, might be a little bit confusing, take 10 to 30 minutes to write the logic out for this, but a simpler method might be to just update the colors of the blocks based on their neighbors' colors, and then that's all you need to do. You need to temporarily save the colors of the old ones and then update them to the colors, their new colors, and then, you know, discard the old ones. So that should be significantly, hopefully, simpler than this. So I'll go ahead and delete all this. No need to worry about that for now. Maybe I'll regret that. You know what? Maybe I'll keep this just in case this doesn't work out. I'll make a new function, just call it new rotate, and I'll change the name later. So all we need to do for this is we'll start with the bottom left again. We'll get the bottom left block, and we want to rotate clockwise, which means the block that is currently the old BR block at the bottom right here is going to move into the BL slot, which means we're not actually moving anything, but the block that's currently at BL needs to inherit the color from BR. So we need to save if BL is the first in this chain of updates, we need to save BL's color somewhere so that when we overwrite it with BR's color, we don't lose it when we need to end the chain by updating TL's color to the old BL color. So we need one temporary Boolean, which will be, I'm just going to call old BL, old color BL. So we're going to say get is color 1, set old color BL to the current old color of quad BL. And then we can do a sequence, I suppose. Where at each execution pin here we're going to change one of the quads to its appropriate neighbor's color. And then we'll run some sort of other function that actually changes the color based on the current value of the block's, Boolean value here. It will check that and change the color appropriately. So we'll have to run that function on each block after we update their colors to actually affect the change. But for now, we're just going to update the Boolean. So we're going to change old BL, or the actual BL quad block, to the current value of BR. So I think we're going to have a lot of wires coming off of this game mode reference, but that's totally fine. So we set the isColor1 Boolean on BL to the value of the isColor1 Boolean on the current BR. And once we use the current BR's Boolean value and we've used it to update BL, we no longer need to worry about preserving it because it's done its purpose for this rotation. So we can now overwrite BR's value with TER's value. So let's compact this a little bit if we can. Due to the way that Blueprint scales when you zoom in and out of a graph, you can get something aligned that looks, decent. Well, this doesn't look very good at all. In fact, I should do this. But you can get something to look okay, at one zoom level, but then when you zoom out, the nodes will sometimes change size and overlap at zoomed out angles, but then look good when you zoom in. But so I try to make it look good at max zoom because that's how I'm going to inspect things usually, or one or two zoomed out. But that's not important. I guess I could just, I don't like having multiple get references to the same object when I don't need to, so I could just have a bunch of blue wires coming out of one node. Or I could have, the same node duplicated for each step in the sequence. It really doesn't matter at the end of the day, but when you later on, when you go to do a search to find all references to this node, like if you do a find references, then your search results here will get unnecessarily long and clogged up with a bunch of references within the same function. Say you have 20 functions and you have 200 references to game mode throughout all of them. You don't want to have 5 of those references be unnecessary because they were all in the same function when you're searching for a specific, trying to find the needle in the haystack for something going wrong. You have to look through the same, hopefully that makes sense. So I try to not have multiple references to the same get node unnecessarily, but sometimes you can't help it for the sake of organization. I've babbled long enough. Let's do the next step here. Get quad TR and get this one's current color. And set quad BR. Oh no, get quad BR and set its Boolean. You can't really copy and paste these because they are, references within from a reference. So if you just copy and paste this, you can't drag and replace these as easily. So I'm just going to drag everything out manually. Now we've used quad tr, now we're going to update quad tr. Oops. Believe it or not, this is simpler than the other implementation, even though it looks all spaghetti right now. So yeah, you have to make the choice of whether you prefer this ugly spider web thing or a bunch of nodes that keep the spider web at bay, but could result in more strenuous searches later on when you're trying to find all references to game mode in your entire project. That can get a bit hairy too. Okay, so now we've used quad TL's color to update quad TR. So now we can update quad TL, but to update quad TL we need to use our local variable temporary value that we backed up from BL before we overwrote that. So we will get quad TL and set is color 1 to the value of our old Boolean. And now that we have all the colors set up, we need to just, maybe we don't need anything. Let's find out, see if that works. I'm sure there's something I'm not thinking about right now. We'll see how that works for now. To test this more, well, first let's just see what happens. Okay, yeah, they're doing that because I'm not actually calling the function that I just wrote. So I need to go back to the event graph and call new rotate blocks. And it's not doing anything because I'm not changing the colors. As I said, it couldn't be that easy, right? I need to call some sort of new function that is currently unwritten. And so now what I'm going to do is one last time use the game mode and call get quad elements, so I can run a function on every quad element. And that function is what I have yet to write, but it shouldn't be too hard, where we can do this in the block, and it'll be a function that is just this, you know, it's already written. It's this function right here. We'll call it once on construction, but we'll also call it again whenever we need to update the color. So let's just call it set color by Boolean. Or update color based on Boolean, you know, whatever you want to call it. That makes more sense to you. Update the color of this block based on the current value of B is color 1. So we'll just copy this into that function. I like to add return nodes. They are not necessary in functions, but they I like to be explicit about ending the function. Usually, I often forget, but I try to make a habit of doing that. So on construction, we call that function once. and then we will call that function again at the end of the rotation functions on each block. And then we're done with that, we will return from the rotation function. I'm going to give this a bit more space visually compared to the other ones to demonstrate that it's a different thing. So that seems to be working, but obviously it's hard to tell if it's working properly when there's only two visually unique states, right? You know, the top left block here could be moving properly, or it could just be shifting between two states. So if we change this to have just one color be different when we spawn in the quad, so for instance, we do it like this, then it'll be a bit more visually obvious that the rotation is happening properly there. The one different colored one is moving properly. So that's rotation in one direction, and to do the rotation in the other direction should be pretty simple. We just modify this function. So we can actually copy this function, duplicate. You know what, before I go duplicate, I'm going to go ahead and delete this function because we now know we no longer need it and don't want to clog everything up. So I'm going to delete this old function and then compile and then change the name of this function to that old name by just removing new here so that it's not confusing about why it was called new. Make sure it still works. Duplicate this, call it counterclockwise, and still save BL, but now we just need to change all these around. So instead of using BR to update BL, we're doing a counterclockwise now, so we're going to use TL to update BL, and then TR to update TL, and then BR to update TR, and then the old BL value to update BR. So just a few snips and replaces here. So we just updated TL. We just updated BL with TL's value. Now we want to update TL with TR's value. Clearly. And then we want to update TR's value with BR's value. And then we want to update BR with the old BL value. And then update the colors, and I think that should be correct. So let's again rotate clockwise, and then the silver block rotates clockwise. Now if we rotate counterclockwise now, I didn't set up the event. So if we rotate counterclockwise, call the rotate blocks counterclockwise function. Now rotate counterclockwise, rotate clockwise, counterclockwise. Ta-da! So that's good. Now we have rotation and movement of the quad. I think I can move these closer together. we do need the drop functionality, so when you press the drop button it will move all the way down to the bottom, or when it hits something. So I believe what we should do for the drop function is basically have like a while loop. So like, or keep repeating the move down, keep repeating this move down functionality until you hit something. So just like it'll call this multiple times. So probably need to break this down into a function. And that might also be the case for all these too, so that we have when you hold down the button after a certain amount of time, you want the action to be repeated somewhat more rapidly. I believe that's the case for some puzzle games. It probably depends on the specific game, but you hold down the left input and you want it to move once and then kind of stop, and then if it sees you've been holding down the key for a long time, then it's going to start moving the block into the left multiple spaces with a shorter delay between each movement until it's like more rapid. But that's a fine-tuned gameplay detail that we probably won't get into in this video series, because I'm just trying to implement the basic functionality of the game. You're certainly more than welcome to expand upon this and improve it. That's just I can't make Lumines as good as the people who made Lumines. Otherwise I would be making that game. So I will just go ahead and break this functionality down into functions right now, because it'll clear up the top level event graph, and we may need to reuse this for the thing I just talked about. So let's go ahead and do that. Let's break this down into a function called move blocks left. You could even call it move blocks left 1 grid space or something like that if you want to get really specific. Might not be a bad idea to do that specifically for this one so that it's clear what's happening. When we call the drop function on it. So now we have a very simple one-to-one input to function call. But before we implement the drop functionality, we want to establish borders on the grid so that the player can't move their blocks outside the grid. So we'll go ahead and do that now.